everybody, and welcome to my YouTube channel. So today we're going to be dealing with tutorial sheet 4, 4, and it's based off of integration. So I'm going to answer selected questions in this. I specifically chose the ones that I felt were the hardest. So we're gonna start with A. So A tells us to find the integration, to integrate 12 over 23. So how we're going to do this is, so with integration, what you're going to do is you're basically going to have, let's say x, right? What you're going to do is you're going to add plus 1 to the power, and then whatever new power you get here, you're going to divide it by whatever you have plus 1. The new power, you put it there. So how we're going to do this, one has no x at all, so we're going to, so the x here, so it's basic, so it's, we can rewrite it as 23x to the power 0 dx. So 0, so now the part of integration, we're going to now just add a 0, add a 1, and divide everything by 1. So it's going to be 12 over 23 x. So there's a 1 here, and if you divide something by 1, it doesn't really reflect. So this is our integral. Now, because this is an indefinite integral does not have limits. So here we don't have numbers. So this is where normally they place the limits. This is where they indicate that, okay, there's a limit of this, there's a limit of that. So we don't have that. So it's an so we're going to add plus c. You always add plus c when it comes to an indefinite integral. So now we're going to deal with k. I specifically chose k because it looks like a difficult question. So k, which says the sine x over cos. So we need to find the integration of this. We need to integrate this. So the cos here automatically has an x. So whether or not they write it down, just know that it's always there. So this is what they want us to find. So in this particular question, we're going to have to use what we call U substitution. So it's a pretty simple process. It makes this entire thing quite simple. What we're going to do is that we're going to pick something and make it u, derive the u, and then whatever the derivative of the u that we've chosen should equate to these two, whatever is left, in short. Okay, let me just show you what I mean. So we're going to pick cos x as our u. Okay, and then the derivative of cos x, which is just the derivative of u, is negative sine x dx, right? So one thing we've noticed is that, okay, so the derivative is sine x dx, and that's, if we cover this up, if we cover this, we forget about this for a bit, it's identical to the derivative of u, right? But the thing is, there's a minus sign here, so we need to place this in such a way that what's left here is identical to what's left here. So to do that, we're going to have to move the negatives, the negative symbol to the du side. So it's going to be negative du is equal to sine x dx, right? So that we have all that in place, we're going to take it back into the integral form. So the integration of 1 over u, right? This du will remain on its own. So, and then we're going to put du over there. So things that the du is negative, and so in between here there's an imaginary multiplication symbol. So because it's negative, it will multiply out. So we're going to just bring the minus sign over there for convenience sake. So the thing about integration is when you have a coefficient, you can pull it out and take it here, just to make life easier for yourself. So we're going to pull out the -1 out. I'm going to have 1 over u du. Now we can integrate this. So the thing is, when you are integrating, right, when this goes away, the du goes away. So you're left with this in the middle, this 1 over u. So when integration, when you're integrating, when you have a 1 over anything, x, u, v, w, x, y, z, any of that, this, the integrated form of this is just the natural log of whatever is in the denominator. That's what we're going to apply here. So remember, this and this disappear, leaving you with this. So what's the integration of this? It's going to be the natural log of u, right? But remember, there's a -1, so we're going to put a negative right there. Okay, so the du goes away, but then wait, we're not exactly finished here. So we still need to add the c, because this is an indefinite integral. Whenever you have an indefinite integral, always add a c. So your final answer is this, but the thing is not finished either. This u must be replaced back to what it's for, and the u was cos, so negative natural log, open bracket, cos x plus c. So this is our final answer. So now we're going to answer M, which needs us to find the integration of, or to integrate x minus 1 over x. So for this particular question, we're going to integrate in pieces, because one, we don't have anything to the power here, so it's just basically what's inside. So we're just going to integrate by parts. I think this is a rule, integration by parts. So it's going to actually be the integration of x dx minus the integration of 1 over x dx, right? So remember, when integrating, what we do is we add to a power, and then the new power you get, you divide it by the entire value. So the integration of x, right? Remember here, when you see nothing here, there's just an imaginary 1. So an imaginary 1 plus 1 is 2, right? So x squared, we're going to divide that by the 2 that we have, and we're done. Now when you have 1 over a value, the integrated version of that is the natural log of what's in the denominator. So we have minus natural log of x, right? Now the thing is that this is an indefinite integral because we have not been given any limits. So plus c, and this is our value. And that is all for today. Thank you so much for watching. Please don't forget to like and subscribe.